All right. Hello, everyone. Today we're going to start our new unit. It's about quadratic functions and equations. Today we're mostly going to focus on graphing it. How do we graph it? And finding the vertex, finding the axis of symmetry. Then later on in the unit, we're going to look at finding the roots. I'm going to try to go through this quickly. If you have any questions, please ask later. You can ask the sub. You can ask me when I return. If you need to go back, you have the ability to pause this video. Right. So first of all, what is a quadratic equation or function? Quadratic function is any function that has x squared in it. So typically it's y equals x squared plus x plus a number. We generally label this as y equals ax squared plus bx plus c. So y equals ax squared plus bx plus c. Later on, we'll look at f of x equals this. We've talked about it in a previous unit. F of x and y mean the same thing pretty much. So we just use y when graphing. Right. On this equation, they are going to look like this. Our x squared functions will look like this. So remember, this is in standard form. They will look like upside or like U's. We call this shape a parabola, or they may look like upside down U's. That's still a parabola. But it's either facing up or facing down, one or the other. And there'll be a mirror image. On here, we have the y-intercept. The y-intercept is where it crosses the y-axis. So the y-intercept. It's very, very easy to find the y-intercept on our functions because the y-intercept is c. It is just the number that's by itself in the equation. If there's no number without an x, that means it's 0. So it is very, very easy to find in all of our equations. It will be c. Then we have the vertex. The vertex is the point where it is bending back. So this one happens to also be the y-intercept. That's not always the case. In this case, this is the vertex as well, where the point where it bends. So it's going down, where the point where it bends back upwards, or if it's going upwards, the point that bends back downwards. These two are not always the same, and I in fact dislike on this graph that they are. But the vertex is the point where it bends down. A lot of times it is our y-intercept, but it is not always. Right, then we have, this is the function itself. This arrow is the function itself. It's pointing to our graph here. The roots are where it crosses the x-axis. So we've had the y-axis where it crosses that. That's the y-intercept. The roots are where it crosses the x-axis. So it's got one here, one crossing there, one crossing there. So there can only be one y-intercept, but there can be multiple x-intercepts or roots. So usually there could be 0, there could be 1, there could be 2 in this function. So remember we talked about last unit how there's 2 answers for one of these. Well, those are the roots. Those are where the roots are. And we'll focus later on finding them. But there can be up to 2 of them, so more than 1. Whereas there can only be one y-intercept. Okay, and then this line here where it is splitting this, and it's a mirror image on either side of that line. This is called the axis of symmetry. So it is the line, it's just an invisible line that makes it a mirror image on either side of that. Okay, and that's what we'll be finding on. I will not be answering all of these questions on this video. However, the notes will have a more complete set of answers. So the completed notes on Google Classroom. So also follow along with those if you have anything else. In fact, I'm probably only going to do one of each type. So number 2 here says find the vertex, the equation of the axis of symmetry, and the y-intercept of each graph of the function. We already talked about the y-intercept is c, the number that's just by itself. So it's -1. Told you it's very, very easy to find it on our equations. Now, as for the vertex and the axis of symmetry, we are actually required to find the axis of symmetry first, generally. The axis of symmetry is an equation. It is x equals -b over 2a. That is listed at the top of your notes. -b over 2a. If you recognize b and a, well, that's because we just discussed them here. When this is in alphabetical order, that is the coefficients of our x squared and x numbers. So in this particular equation, b is 6. So it's -6 over 2 times, so b was 6, and a is -3, so times -3. And we want to simplify this. So we have -6 over 2 times -3 is -6. -6 over -6 is 1. And you can type that in your calculators to help simplify. But it is 1. So we have our axis of symmetry is x equals 1. And we're going to write that whole thing, x equals 1. So our axis of symmetry is an equation. And what this means here's our graph. This line that makes it a mirror image would be at x equals 1. So 1, if this is our origin, then it's at x equals 1. Now, I don't know if that's fully accurate for this one. In fact, I know it's not, but it's x equals 1 would be where the mirror image is. So this would be the line x equals 1, straight up and down. Okay, and then lastly, we find our vertex. To find our vertex, all we do is take our axis of symmetry 1. Our vertex must lie on the axis of symmetry. It must be the point that's both on the axis of symmetry and the function. So all we have to do, we take our x equals 1, and we're going to plug 1 in for everywhere x occurs in our function. So y equals -3. Well, we're replacing x squared with 1 squared. Plus 6 times, we're replacing x with 1 minus 1. You're only replacing x, not the signs, not the numbers. If your number is negative, you need to put negatives, or you need to put parentheses around it, and you need to put -1 in there. So then we simplify this. -3 times 1 squared, well, 1 squared is 1, so -3 times 1, plus 6 times 1 is 6, minus 1. -3 times 1 is -3, plus 6, minus 1. -3 plus 6 minus 1 is going to be -3 plus 6 is +3, minus 1 is 2, +2. So our vertex is at, it's a point, sorry. Our vertex is not just at 2. It is the first coordinate. It is a point. The first coordinate is always matching our axis of symmetry, so it's 1. The second point, we said that, well, if x is 1, y must be 2, so 1, 2. So you should get half of it for free. It will always match the axis of symmetry. 1, and we have to find our other one. Okay, number 3 is very similar. I'm going to move on to talk about number 4. On number 4, we discuss on number 4 and 5 whether a parabola opens up or opens down. The only thing, so whether it looks like this or this, the only thing that determines it is what number A is. So A being the one with x squared. If A is negative, then our parabola is going to look like this. It opens downward. So this is a negative A. And if it is a positive A, then our parabola looks like this. So if A is positive, then it will open upwards. That's it. That's the only thing that determines whether it opens up or down. Now, on numbers 4 or 5, we are asked to find the maximum or minimum. Well, if this parabola opens upwards, it has a minimum. It ends right here. And then it goes back up. So this is the smallest number we could have. If it opens downwards, then we have a maximum because it goes up until a certain point, then it goes back down like a roller coaster. It goes back up, goes up, must come back down. So here on number 4, A, this is just a negative sign, which means -1. Well, that's negative A. That's a negative A. So it must open downwards, which means we have a maximum then. So that means we have a maximum. Now to find the maximum or minimum value, well, it turns out the maximum or minimum value is always going to be the vertex. So this is the same exact question as asking me what the vertex is. It's just the y value of the vertex. Well, to find the y value, we still have to find the x value. And to find the x value, we're going to have to plug this into our axis of symmetry equation, which was x equals -b over 2a. So get used to that. We're going to do it a lot today, quite a bit next time, next couple of days. -b, we've got negative. We're replacing b with 4. So b is 4 over 2 times -a, or sorry, 2 times a, and we said a is -1. This gives us -4. 2 times -1 is -2. So we've got -4 over -2, which equals 2. So this is our x value. Well, to find our y value, we have to plug in 2 for x. So everywhere there's an x, we're going to plug in 2. So negative parentheses 2 squared plus 4 times parentheses 2 minus 3. Just always put parentheses around these numbers. On this one, for example, our x equals, we'd have -8 over 2 times +2. This would give us -8 over +4, which is -2. So when you found y, you must put in y equals 2 times -2 in parentheses. So just always put the number sign included in parentheses and you'll be good. So if you get a -2 squared and you get -4 on your calculator, it's because you forgot your parentheses. So always put them in parentheses. That will help. So on this one, it would be -2 squared, not negative parentheses 2 squared. It'd be parentheses -2 squared. Okay, back to 4 real quick. Negative, we've got 2 squared. 2 squared is 4, so we've got negative times 4. Plus 4 times 2 is 8. minus 3. Negative times 4 is negative 4 plus 8 minus 3. Negative 4 plus 8 is 4. 4 minus 3 is 1. So what we get y equals 1. Well, this is our maximum or minimum value, in this case maximum. This will be our maximum value. So the y version of the vertex. So the x component is the axis of symmetry, so x equals. Then our y component is our maximum or minimum. So we have a maximum of 1 here. The domain and range. As for this, the domain and range. The domain is easy. All of these have a domain of all real numbers. We've talked about that before. So there's no x number that you could think of that I cannot put into my function. So it goes from negative infinity to positive infinity. I mean, it looks like this, and while it looks like it might stop going to the right and left, it does not. It always goes left forever, goes right forever. You can put 1 billion in, you can put negative 2 trillion in, it doesn't matter. As for the range depends on whether we have a maximum or minimum. In this case, we have a maximum. Because we have a maximum, well, that's like the maximum is like asking, well, what is the top floor of a ceiling, of a building? Well, if this is my top floor of the building, then all the other floors have to be below that floor. So if that's the case, then our range must be y is less than our maximum value, which we said is 1. So y must be less than that. Now, if we have a minimum, on this case, we have a minimum, then the range must be y is greater than the minimum value. I don't know what the minimum value is on this one, but y must be greater than that. So if the lowest floor in a building is the first floor, well then all the other floors must be above that floor. So y is greater than. Okay. If you have any questions, once again, please ask the sub. Please look over your notes. Please ask each other. If you have more when I get back, you can ask me. Okay. And now we're finally going to put all of this together. I'm going to skip to number 8. We're finally going to put all of this together. On number 8, we are asked to find the equation of the axis of symmetry, find the vertex, find the y-intercept, find the domain, the range, the minimum or maximum value, and to graph this. There's some questions exactly like this on the test. First, given, I'll just find these in order. Given y equals 2x squared plus 4x minus 6. I'll just find these in order. We always want to find the axis of, tongue twister. The axis of symmetry first. So x equals negative b over 2a. And you do get these equations for the test, so you don't have to memorize them. Now b is 4, so this is negative 4 over 2, and we say a is 2, so 2 times 2. Negative 4 over 2 times 2 is 4. Negative 4 over 4 is negative 1. So the axis of symmetry is x equals negative 1. The y-intercept. Well, the y-intercept is c. We talked about that before. It's c. So in this case, negative 6. The sign does come with it. So it's just negative 6 and I'm done. It should be the easiest thing to find. So there we go. Maximum or minimum. This is the other half of the vertex. So we found the first half, x equals 1. Now we need to find what y equals. So y equals, since x equaled -1, we're going to plug in a -1 everywhere there's an x. So 2 times -1 squared plus 4 times -1 minus 6. -1 squared, we always follow our order of operations. So this equals 2 times, well, -1 squared. -1 times -1 is +1. Excuse me. +1 plus 4 times -1 minus 6. Y equals 2 times +1 is +2. 4 times -1 is -4 minus 6. 2 minus 4 is -2 minus 6 is -8. So 2 minus 4 is -2 minus 6 is -8. So our maximum or minimum value, it's -8. Well, we also need to make sure we say which one it is, whether it is a maximum or a minimum. Because A was a positive number here, this means we have a minimum value. It must be a minimum. The last two over here, domain, should be a free point. It's all real numbers. It's always that. The range, because we had a minimum value, everything must be above that value. So y must be greater than -8. All the other y's must be greater than that one. Now finally, for graphing it, we need to graph with 5 points. So we did this with exponential functions, graph with 5 points. We need to graph this with 5 points. One of them, you should always try to use the y-intercept. So -6. So starting at the origin, just go down 1, 2, 3, 4, 5, 6. That's the y-intercept. Then my other 2 points, we should start by graphing the axis of symmetry. We said it is -1. So left 1, and we just want a vertical line here. So line straight up and down, x equals -1. So left 1. One of the points will always be this -1 with my maximum or minimum. That's the vertex point. So -1, -8, -1, -8. This is my other point that I'm going to use. So these are my 2 starting points. Now, we need a third point. So I said we have to find 5, but we're going to use a shortcut to find the other 2. So we have to, at the very least, find a third one. We were able to use our y-intercept. I would always use that if you can. Makes this much easier. So we found our first point. Y-intercept is our second point. So we're done there. We need to find a third point. Y-intercept makes it to where we really only have to do the math to find 2 of the points. Our third point, since our y-intercept was to the right of our axis of symmetry, we are going to keep going to the right. So we went 1 to the right, just go another point to the right. Well, the x value here would be +1. Well, because the x value is +1, we're going to plug +1 into our equation this time. So last time we did -1. This time we're going to plug +1. So that way we can find what the y value must be. So +1 squared plus 4 times +1 minus 6. +1 squared is 1 plus 4 times 1 minus 6. 2 times 1 is 2 plus 4 times 1 is 4 minus 6. 2 plus 4 is 6 minus 6 is 0. So if x is +1, then y must be 0. So this is a third point. We say, hey, if x is here, then y must be 0. Now, as for our last 2 points, we can pretty much cheat those ones. We talked about earlier the axis of symmetry. It is a mirror image. Our function will look like a mirror image. Remember, it's going to look like a U or an upside down version. Well, it looks like a mirror image on either side of the axis of symmetry. Because of this, we can just take our points. This was one to the right here. Well, we want the same one to the left. This was 2 to the right here. Well, we want the same 2 to the left. We can cheat it. It's got to be a mirror image. Then we're going to connect these. It will look like a U. So make it a soft turn here. Do not make it a V with a hard angle. That is a different type of function that we probably won't get to, but that is an absolute value function. We want it to curve, be curvy. Okay, I know I went through this fast. Please, especially this last part of how we get our 5 points, please look over the notes for how to get that. Look on YouTube if you need any more examples. I would say Khan Academy is a good place to start. You can rewatch this video as many times as you need. You can look over the notes that are completed and posted on Google Classroom. If you need any more questions, or if you have any more questions, please ask the sub. Please ask your seminar teacher, especially if you have a math seminar teacher. They'll know how to do this very easy for the math teachers anyways. And then ask me when I return.